we talked about the factorial function and about the permutation function. And now it's time to talk about the queen of combinatorics function, which is the combination function. And we're going to do it in two ways, just two perspectives on the same function. Okay, so the first is selecting a set, or in other words, suppose that we're asking how many different ways are there to select 3 out of 7 objects where the order doesn't matter. So think about the bins that we had before, but now the bins are not marked, so they're all identical. Or to make the point even clearer, suppose that we just remove the separators in the bin. So we just need to put 3 objects in here, but it doesn't matter in which order they're put in. Okay, so for instance, we can put the monkey and the lion and the dog in, and the order doesn't really matter. Okay, so here's an example. So suppose again that we're taking the lion and the monkey and the dog, and so this is one way to order them in the bins, and here's another way to order them in the bins. But if we don't have bins, then these are identical, and so we need to divide by the number of possibilities. So what does that give us? We can say that we first take P of 7, 3, so that's for putting them using the permutation function to count the number of possibilities, and then we need to see how many times we got each set, and that is basically the number of ways to place 3 objects in the 3 bins, and so that's divided by 3 factorial. Okay, so and then multiply that by 3 factorial. Okay, so that second multiplication was because this 3 became this 3. Okay, so this is the permutation function, the combination function, and it's can be written as C7, 3, or also 7, choose 3. These are the common ways of writing it. Okay, now let's look at another way of getting to the same function. Suppose we are now in a situation where we have our bins, and the bins are marked, but we have different objects that are, we have animals that are identical. Okay, so we have 3 lions and 4 pigs, and what we're interested is in placing them into the 7 bins. Okay, so let's say we can put a lion here, a lion here, a lion here, and a pig here, a pig here, a pig here, and a pig here. And these pigs and lions are, the pigs are identical to each other and the lions are identical to each other. So how can we calculate this? We again are going to use the idea of overcounting. Okay, so let's put these back where they were. And what we're going to do is again 2 stages. First, we're going to consider each pig as a different pig, and then we're going to divide by the number of possibilities. So we have here 4 pigs marked A, B, C, D, and 3 lions marked A, B, C. Okay, so now the number of ways to put them would go something like this. Maybe we'll put this line here, and this line here, this pig here, and this pig here, and this pig here, and this pig here, and this line here, okay? And the number of possibilities for doing that is clearly 7 factorial, okay? And then we need to divide by the number of possibilities for permuting the lines, because the lines have labels, but these labels are now irrelevant. So we need to divide by the number of possible ways to put A, B, C. So that's 3 factorial, multiplied by the number of ways to permute the pigs, which is 4 factorial. And again, we get that this is equal to 7 factorial divided by 3 factorial, 4 factorial, which is C 7, 3, or 7, choose 3. Okay? So that's what we get. And now let's write a general kind of equation for that. So maybe we'll move this a little up and move this down. And now focus on this area here. And what I'm going to write is the general equation for the combination function. So n choose k, which is also c n k, is equal to n factorial divided by k factorial times n minus k factorial. Okay, so that's the general equation, and that's more or less it for the combination function.